Hello, everyone. This is Maryna Hritsyshyna, and I want to welcome you to the next episode of the podcast Clean Energy Talks. Today, we will talk about electrolysis technologies with Carlos Bernuy-Lopez. Carlos is a senior consultant and thought leader at Ramboll. He has over 18 years experience in hydrogen-related technologies and has intensive international experience in both academia and industry. Throughout his career, Carlos has worked at research institutes and universities in Spain, the UK, France, Denmark, Norway, and Japan. At Ramboll, he is dedicated to bringing power to X projects to reality. In this podcast, we will talk about the electrolysis technologies and examine the key trends globally. There are different technologies for hydrogen production. At the same time, in the regulation in the EU, the main focus we have on the electrolysis technologies. Carlos, why does electrolytic technologies still dominate?
Yes, hello, Marina. Thanks a lot for having me. This is very nice. It's a great opportunity to talk about what I've been working nearly all my life. And answering to your question, we are paying attention to electrolytic hydrogen because it's most likely the best manner to obtain what we call clean hydrogen, to obtain hydrogen with the less emissions as possible. We need to realize that when we produce the different types of hydrogens of those so many colors over there, we obtain them with different CO2 footprint because it has different methods, different um, manners to produce it, and the electrolytic one, the one that we do with water electrolysis, is the one that end up with the less emissions when we look at the scientific papers done recently on this topic. Yeah.
When we consider production of hydrogen, especially renewable, we discuss a lot about renewable electricity. At the same time, we know that nuclear energy is also one of the options for reduction of greenhouse gas emissions. And the production of hydrogen using nuclear energy can also contribute to reduction of emissions. However, we have different regulatory approaches to hydrogen production from nuclear energy in the EU and in the US, for instance. And from a technological perspective, are there any differences in the production of hydrogen from nuclear and renewable electricity using electrolyzers?
Not in the very basics of it. We are using water electrolysis that needs electricity to break the molecule of water. So what you need is clean electricity to end up in clean hydrogen, right? So that clean electricity could be nuclear or could be renewable, as soon as we agree that nuclear power is clean, right? But that's probably a debate for another podcast. So,
Yes.
but one thing that it must be said about the nuclear energy and electrolysis is that it has several advantages of the use of nuclear power as electricity source for hydrogen production, as it will be quite constant on the load that we supply electricity to the electrolyzers, something that the electrolyzers likes a lot. Electrochemistry would like to do the reaction constantly without any stops and variations in the current. So when we have a good nuclear power plant kind of delivering good constant load, that's a nice thing for the hydrogen production. At the same time, we have the excess heat, we have the water in the nuclear power plants that could be also used in one of the technologies in the high temperature electrolysis that we can talk a little bit later, to increase the efficiency of the method and get cheaper hydrogen at the end of the day. So It is not a completely crazy idea to think the hydrogen production together with the nuclear power plants, because it's true that it has some synergies and things that they could profit one from each other. So no.
Yeah, but it's still this topic is very difficult because Germany decided to refuse from nuclear. France has nuclear, so it's quite difficult to discuss this topic for hydrogen production. Um, Electrolysis technologies are not a new one. So we know about this technology maybe 100 years ago. They are well established now. And is there still room for innovation and research and development projects in this area?
Sure, sure. The technology is not new. But let's say that the level of the quantity of equipment, instruments, materials, components that we need is not as we were having. So it is not that we don't know how to make an electrolyzer or how to operate an electrolyzer, but it is true that it is coming new, the level of the amount of electrolyzers, of instruments, equipment that we need to have, and then all the different components that comes associated to it. So when you are developing a technology and scaling it up, they come a lot of possibilities of improvement related to the performance of the material, even the combustion engines. That is a technology very old. We've been continuously improving it through innovation and good R&D work. So in here it's even better because the room of improvement is larger now. Then of course we will get more and more pushed by the room that we will have. But I would say that the main topics would be regarding the materials, uh, trying to obtain the cheapest and high performant materials, and then that we have high efficiency also in our systems, that the systems are well designed and we have a good design of all these equipments to produce efficiently hydrogen.
It's quite interesting that there is a lot of opportunities to advance this technology that take into account that it's rather very mature technology. At the same time, as I mentioned maybe several times, that we focus in the EU mostly on electrolysis technologies. And it's interesting to understand from technical perspective, do we have advantages and disadvantages to these technologies, in your opinion?
I mean, I think the main reason that the EU was focusing electrolytic hydrogen is because our potential to produce lots of renewables in many parts of the continent. It's true that in others we are much more in trouble with that, but that's something that we need to work together to see how we bring all these things. And the other types of hydrogen are based on natural gas. There is two main types of what it is considered renewable hydrogen, that it's the blue and the turquoise. So the blue is the one that you would use um, you take the natural gas and then you capture the CO2. You form the hydrogen from the natural gas, and then you capture the CO2. And the turquoise is where you take the natural gas and you do the pyrolysis of that methane molecule, and you obtain the hydrogen and carbon. As we don't have much more source of natural gas, it makes sense that we in Europe focus on renewable energy, on electrolytic hydrogen. That is not only renewable but also with the nuclear, as we said at the beginning. The main advantage would be our access to it, our possibility to produce it. The disadvantage, I would say, that it comes from the own nature of our access to the renewable hydrogen. It's very uneven. It's not gonna be the same, the hydrogen produced south of Spain, north of Sweden, than the hydrogen produced in Germany, and we will need to find mechanisms to make it to work and to create a good internal market, and at the same time outside market, to profit of the whole economy around it. So
You mentioned in previous answer about the critical materials that is important for components of the electrolyzers. If I correctly understand, in the EU we do not have all critical raw materials for production of electrolyzers, and the key topic is to secure the supply from other countries. From your opinion, is it possible now in the EU?
well, I guess that this is what the EU needs to work in close collaboration with other countries, with other regions. But I see also a possibility with circularity manners. 98, 99% of the materials can be recycled. So once that you are manufacturing and you are producing and you are having, so you are a good producer of electrolytic hydrogen in the continent, you get your own mines a little bit, right? So that would probably allow us to not be so dependent from outside. But now, at the beginning, I think it is a challenge to secure the materials and the supply chain that we need in order to do that. I think it's an issue that we have with all the technologies, because we are lacking most of them. So
It's an important topic, but when we consider from practical perspective of the project, maybe the main question for each project developer is costs connected with the development of the project, especially for equipment, and the main equipment for hydrogen production, if I correctly understand, electrolyzers. So are there any significant differences across different types of electrolysis technologies in regarding costs?
yes, there is significant differences. There are four main types of electrolyzers these days, divided in the type of temperature that they operate and the chemistry that they had inside. We normally refer to alkaline, PEM, and solid oxide. And then we have also the AEM, the anion exchange membrane. And they are different in terms of the different materials that they use. PEM technology is associated with much more costly materials, PGM metals like platinum, like titanium. It's in there. The alkaline ones have a considerable amount of nickel, although this nickel is being substituted by steel, or by nickel-plated steel, so it's kind of reduced in the utilization. And then the solid oxide is the one that would use the less expensive materials. It's made of oxides, as it said. It's metal transistors oxides that are much more abundant and cheaper than the metals. That's what the other technology uses. Anion exchange membrane would also use not very expensive materials, still a lot of nickel. The nickel is not one of the worst, but is something in the middle, I would say. It's not cobalt, to kind of say to someone who could understand, but it is not steel either. It's not iron, what it is quite easy to find, right? So it is important to understand the differences, to you to see if this is going to create a problem in the future or in the near future, depending of your supply chain of materials. Yes.
So if I correctly understood, the price, the cost depend on the materials used, raw materials used in
Yes,
production process.
mainly. It could be associated to some technology development, but I think it's will be driven mainly by the material cost. Yeah.
Mm. Quite a useful term for understanding. But except costs for equipment, I think the second question should be efficiency of this
Yes.
equipment, and which technology is the most efficient.
So the most efficient is the solid oxide, is the technology that works at high temperatures. By high temperatures, we mean above 500 degrees C, 550 degrees C, and they could operate up to 800, 850. And those have efficiencies between 80 and up to 95% because you could actually put heat to it and it works in a different thermodynamic regime than the other ones, and it can become very efficient. On the other hand, the low temperature technologies, they are between 60 and 70% efficient, more in the 60 than in the 70%, depending of the manufacturers. And then it is more because it is low temperature and you need to push you need to overcome a lot of overpotentials that you have at lower temperatures and you have the advantage that those technologies are more mature because are the technologies that we've been using the most over the last decades. And in the case of the alkaline technology, it is a rather cheap technology these days and quite well spread, and it comes. It is the readier, it is the more ready technology to be used these days for nearly any developer, depending, if they want to even do a very large project. Most likely, they could have options in alkaline much more than in PEM and much more than in SOEC. AEM, alkaline exchange membrane, is the less mature of the four of them. Yeah.
So my understanding from our discussion that electrolysis looks like a simple technology, but in fact it's not simple because, as you mentioned, there is a lot of options for improvement, and at the same time, everything depends from the raw
Yeah.
materials that is used and
One
some
one
other.
thing one thing to realize when we talk about hydrogen production is that even if the electrolyzers are the more important piece of equipment, the electrolyzers themselves are already quite complex. They have four or five building blocks quite specific to be designed, to be constructed. It comes different parts of the engineering and the science and the scientific world to work together because it has electronics, material science, it has process engineering, it has different things together that you need to put. And then in top of that, when you are normally producing hydrogen for an industry, that is most of the cases in the hydrogen applications, you are dealing with a chemical plant. So you are also dealing with other type of equipments that you need to get used to or learn how to use because of the handling of chemicals. It is a gas, you may want to compress it to a storage, then you need to deal with the storage, then you need also to deal with the water purity, you need to treat the water. So it's not a battery, for instance, is much more complex. It's much more simple equipment. I'm not. Don't get me wrong here. The battery people not saying that their equipment are easy to make, but the other ones are much more complex, much more, yeah, large also in size. So.
It's very challenging, I think, for the project. So I just imagined we have a lot of rules, technical rules for use of electrolyzer in order to have good efficiency. At the same time, we have a lot of difficult rules and delegated acts. And maybe for the project, it's quite difficult to combine both technical and regulatory requirements.
Yeah, it is. It is. It is sometimes it takes time. I mean, we have learned, been since the boom came in those 5 years, our level of understanding on how to build a hydrogen plant has come much more better. It's nothing to do. Before we were very much focusing on the electrolyzers. We thought that okay, with an electrolyzer, everything was fine, but we have found other things quite complicated. That it comes from the nature of yeah, these are large chemical plants with a rather complicated gas to handle. Hydrogen is not the easiest gas to probably handle. So you need to really make sure that safety is in place, that we do things right, that there is no these emissions that it could be also from hydrogen if you don't do the connections right and so on. Same problem that they have with natural gas. So those things add complications as you are realizing them because you are making the projects. Before in the PowerPoint, things look very easy
Yes.
and straightforward. But then when you start to kind of make it, is when. But all the technologies has gone through this step, so it's not the first time. Hmm?
Yeah, it's true that in part points it's look not so difficult. So, and the last question, could you provide some advice for those planning to select electrolysis technologies for hydrogen projects? What do they need to take into account for selection of the electrolysis technology?
Yeah, one maybe the first advice always is to be as agnostic as possible with technology, manufacturers, and trying to base decisions on good data. We have done a very good job during the last decades, I would say. Electrolyzer manufacturers are not 2, 3 year old. They are much more. I started my PhD 20 years ago, and back in there, most of the companies that we hear now, they were already there trying to develop their products. So that's a first thing to realize, and then understand the advantages and disadvantages of each technology to see if it matches to your own circumstances in your project, because your project will be quite different to the project, I don't know, 1,000 kilometers away and in a different country. So don't think that because someone in Germany is using alkaline, you in Spain will use also alkaline. Um, your projects may be completely different for a different off-taker with a different electricity profile, and those are the things that you need to really understand well with the characteristics of your electrolyzers to have a good pick of the technology. That would be the main pieces of advices that I would give here in just 30 seconds.
Thank you very much. Thank you for your participation in podcast and very insightful discussion.
Thank you very much, Maryna. Thank you. And I keep encouraging you to do this because it is very nice for everyone. Thanks a lot.
Thank you.